Hey everybody, I'm Kathy Resnichek.
And I'm Richard Pressler.
And we are going to be covering the final assignment in Module 1, which is in Network Fundamentals and the Tapped Wired Networking Program. So last but not least, what's the exciting conclusion to this module?
Well, now we've done the lab work, you could say. We've done the hands-on work that we were able to do by looking at the physical aspects of a computer network. And now we're going to talk about a model. And what a model is, when we use that word in this context, we're talking about something theoretical, something that you could basically draw out, but it describes a network in very broad terms. Now there's several different models that you can review to understand computer networks. The one we chose is the OSI model, the Open Systems Inter-Network model. And the reason that I chose that model to discuss is because it's broad enough to cover all other models. It's broad enough to cover any protocol at any layer, basically.
So it's the mother of all models.
Yeah, and some people feel it's kind of clumsy because it is actually a little bit too large, and I'll dig into that a little bit for you. But essentially it divides a computer network up into 7 layers, and those layers essentially dictate how programs or applications at the top would communicate all the way down to the cabling at the bottom, or wireless communication. Somehow the bits have to get from point A to point B. So as an example, let's say you have an email client, and that email client is going to communicate with an email server. Well, the email client has to speak the same language as the server in order to collect the emails, right?
Right, that would make sense.
And speaking the same language actually goes even deeper than just how do I send an email. It goes into the TCP layer, it goes into the IP layer.
And these are all protocols. Explain all those, what TCP and IP and all that stuff
we get a little bit here, and then we get a lot in Module 2.
Okay.
Module 2 is really deep into all of those protocols.
Okay, great.
But this gives a framework to understand where those protocols even fit.
Okay.
It also gives a good framework to understand where equipment fits. So for example, when we say a switch, well, once you've read through this model and understand it, you'll say, well, a switch is generally operating at layer 2 of the model. When you say I have a patch cord, a cable, that would be considered layer 1 of the model. A router would essentially operate at layer 3 of the model. Now when we get above layer 3 is when it gets kind of tricky, because some people would claim that once you get past layer 4, which is session reliability, it's the ability to guarantee that 2 parties are communicating with each other and actually receiving the data.
That's important.
But once you get beyond that, you are getting into applications. And that's really the territory of programmers for the most part. So layers 5 through 7 are considered to be things that you need to understand when you're developing applications that are going to speak on a computer network. So we're not going to spend a lot of time on that, because most network equipment doesn't really look at layers 5 through 7, other than some very expensive, very nice next generation firewalls, and some routers that have the ability to identify applications. Beyond that, for the most part, network equipment looks at layers 1 through 4. And that's where we're going to spend a lot of our time.
Great. That sounds really good. So you talked a little bit about the different layers. And so for someone who is responsible for the network, the understanding the OSI model really gives them that understanding of where each piece of that network sits in those 4 layers. Is that right?
Yeah, it's a way to contextualize things and to organize it, really, is what it is. So let's say, for example, that you're reading a paper, and that paper is talking about some new protocol that someone created that works within an IP network, right? And perhaps this is a protocol that's designed to help phone handsets communicate with each other better, that maybe somebody came up with something. Well, if you have an understanding of the OSI framework, what that does for you is it helps you just kind of plug that new piece of information into where it sits in the entire stack, so that you understand what goes under it and what goes above it. As you've learned up to this point, you can't really have a wired computer network without wires or fiber optic cabling. You can't really have a wired computer network without switches and routers. Well, when you talk about protocols, you also can't really have a wired computer network without protocols, because people have to be able to talk to, or computers have to be able to talk to each other, I should say.
Well, people
too,
but we don't have those protocols in place so much as we do for computers. But
well, there you go. And so when two computers are speaking to each other, it's important that the developers who basically wrote those protocols for those computers were on the same exact page, and that they can communicate in the same language. Yep. And so understanding this model helps you to understand where that's possible and where it may not be possible.
It sounds really interesting.
I hope it is.
And I think it's a great way to wrap up this module, because it kind of ties all those fundamental pieces that we looked at earlier, and it puts the theory behind the practice.
Yes, that's my hope.
Okay, great.